So today I'm going to be talking about Xelsius as a versatile reaction platform for synthesis and reaction optimization, as well as many other applications which we'll be exploring later on. As with all the webinars in the series of webinars that we're doing this full year, we're going to be putting a really strong focus on applications. So that again will be the focus of today's presentation. I am, however, going to kick us off with a little bit of technical detail on the system itself, just to provide a little bit of background. So firstly, let's just explore what Xelsius actually is. So Xelsius is a 10-in-1 reaction station capable of independent temperature control and stirring in all 10 positions, providing both rapid heating and cooling from -20 degrees Celsius all the way up to 150 degrees Celsius, all in a very compact design. You can see the design of the system on the right-hand side of your screen. You can see that the system is modular. So we have our reaction module on the left. This is what's actually doing the heating and cooling and where our 10 positions are sitting. On the right of that, we then have our control module. So this is the intelligent part of the system. It's what's controlling all our sensors and relaying this on to our interface. You can see our interface there. It's a 10-inch touchscreen display with a really intuitive software, which we'll be exploring later on. So the technical specifications are what really define Xelsius. So it's got a really compact design. Each module is just 36 by 16 centimeters. And we're also able to stack these modules. With the whole concept here is just we're trying to reduce the amount of fume cupboard space that we take up. It's a critical stumbling spot for most labs and something that we're really targeting here. Nextly is the really rapid heating and cooling ramps that we're able to proceed with. So we can ramp at a rate of 48 degrees per minute and cool at 36 degrees a minute. Importantly is then our temperature accuracy and stability of plus and minus 0.1 degrees Celsius. This is really important for fine temperature control in particular reactions. A good example of this is crystallization studies, where that control is really important. As mentioned, we've also got stirring in all 10 positions using a magnetic flea. We are allowed to control stirring from 0 to 1,500 RPM. Next is our applications. I am going to look at applications in more specific detail later on, but just to give you a quick overview now, there are absolutely tons of applications, and it's essentially any heating or cooling process. Xelsius is used in academia and industry, particularly in the pharmaceutical markets with the likes of your CDMOs and CMOs. Some specific applications include your design of experiment and scale-up optimization. Here, Xelsius is a brilliant tool in which we can try 10 different reaction parameters all simultaneously. We can then analyze the results and see which one's the best, and we can then carry that forward. We can also do your general chemical synthesis reactions, be it API synthesis, drug discovery, crystallization studies, and flow chemistry. Again, I'll cover these in a little bit more depth later on, but it's just a nice way to give a bit of background. So how are we actually able to do these reactions? I'm going to start off by looking at the hardware. So this is our reaction module. So on the top right of your screen, you can see this reaction module. It's coated in acid and solvent resistant PTFE. You can see that it has 10 reaction positions. This is where our vials actually sit. On the bottom hand right side of your screen, you can see the Peltier modules. So these Peltier modules are really the heart of the system. These are what are creating the heating and cooling effect. Depending on the direction in which electrical current flows through these Peltier modules, we're able to really efficiently heat or cool. And it's these modules that allow us to have one position at -20 degrees and one at 120 degrees, for example, or anywhere in between. We have sensors in each of these Peltier modules, which are constantly measuring the temperature of our samples. The system then uses PID control to maintain that excellent temperature stability whilst following a isothermal or ramp profile. So vials and stirring. To match the individual needs of each lab, there's a range of different vial types available. Um, we have the option between glass or PTFE vials. Glass vials are available in both 5 ml and 30 ml, and that gives us a working range of 0.5 mils up to 30 mils. On the top of your screen, you can see our 30 ml vials. We have a rubber septum and plastic sealing lid that form a seal on our vessels. We also have a larger magnetic flea for these vessel types. For our 0.5 mil vessels at the bottom of your screen, you'll notice that we have the same diameter at the top of the vessels as we do to our 30 mil vials. We do have a very narrow bottom. This allows us to work down to 0.5 mils. When using this vessel type, we need to use a metal adapter that you can see on the screen there. That sits at the bottom of our reactor chamber or cell, and it just enables really good heat conduction from our heating element to our sample. We have the tool on the left there, which allows us to really easily take out these metal adapters, allowing you to rapidly switch between 30 mil and 0.5 and 5 mil vessel types. Finally, the terminal. So here we've got a 10-inch touchscreen display, really high resolution with glove-sensitive display. A really nice feature is we've got an extendable cord that allows us to operate it outside the fume cupboard. So we can have our actual reaction block and control module sitting in the fume cupboard. We can have the fume cupboard door shut, and the user can completely control the system from outside there. We've got a Windows 10 operating system, which allows for a really intuitive interface and software, which we're going to be covering in the next few slides. So Xelsius has two principal modes of operation. The first being isothermal operation. Here we're just heating to one temperature and we're holding for a set amount of time. On the left side of your screen, you can see the control center for Xelsius. Each of those green squares relate to a specific position on Xelsius. So there's 10 positions. On the right side of your screen, you can see where we would input different parameters. So in this example, we've set the jacket temperature to 40 degrees. We've put the ramp as 0, in which case it'll ramp as quick as it can. We've got no stirring and we've got no time, which would be infinite. We can then set quickly what positions we want to run this method by just tapping the gray circles on the left and right of your screen. We press OK and it is then ready to run. So isothermal is the most basic operation method and really clear and easy to use for everyone. Slightly more complex is our ramp profiles. Here we're just following a classic ramp profile. All of the boxes that you can see on the terminal there, we're able to modify. So be it stirring, hold time of that stage, and temperature. Interestingly, we can also edit the number of ramps. So in this example, we've got 3 cycles of this ramp. So it will heat, hold, and cool, and repeat that 3 more times before finishing at that -5 degrees hold for 3 hours that you can see at the end there. What's nice about this is that we're able to save any ramps that we've created, and of course apply ramps from our catalog to use whenever we want. For your reaction optimization work, it's a really useful tool. What we see is some labs like to pre-save 10 different ramps. They then, when they're going to test a new reaction or new reagents, they can run all 10 methods simultaneously and again see which one works best. It's just a really fast way of designing methods or performing reaction optimization. So exporting data. So for all 10 positions, we have simultaneous data logging. And that means continuous measurement of jacket temperature, sample temperature, the set temperature of that ramp or isothermal hold, and also the time of the reaction. On the right, you can see a live temperature trace. So this is what you'd be able to see in real time for all 10 positions. You can see on the red line there is our sample temperature or jacket temperature, and it's following closely the ramp that we've set. Because the data that we can gather is so excellent, we really need a complete way of exporting this data, and that's something that we're able to do. So firstly, we can export directly as an Excel datasheet. You simply input how often you want to take a measurement, and you'll put this straight into a datasheet. We can export as a CSV file, and we can also export as a graphic representation on a PDF. So much what you can see on your screen, this would be directly exported as a PDF. The system, as it works on Windows 10, we can set up shared drives on the folder, so you can save your data directly to a shared file, which you can then access on a different device. So it saves the need for using USBs, which are available if needed. So before moving into the applications, I just want to do a quick overview of what we've looked at so far. So firstly, for the hardware, we've seen that it's a really rugged system. It's capable of independent temperature and stirring control in all 10 positions. We've got a really wide range of temperatures, so -20 to 150 degrees Celsius, with very rapid heating and cooling rates, as well as really fine temperature stability and temperature accuracy. Has a really small footprint, takes up very little space in a fume cupboard, and it's also designed to have a very long lifetime with PTFE coated surfaces to protect against aggressive acids and solvents. In terms of the interface, it's very intuitive and user-friendly. We've got two principal modes of operation, our isothermal holds and our ramp cycles. We also have complete data collection and export options. So now we're going to look at our accessories. So Xelsius in its basic form is what we've talked about so far. What really targets Xelsius towards specific applications is the accessories that we choose to bring alongside it. For all of the accessories, I'm going to use a application report or method that we've developed just to show how this accessory works and how it's enabling this application. So let's start with potentially our most popular accessory. This is our reflux condenser. This reflux condenser sits directly on top of Xelsius on the reaction block. It connects to a chiller and it creates a cool band at the top of our vessels. And this is really important because it prevents the buildup of condensation and promotes reflux in our vessels. This is particularly useful when we're heating low boiling point solvents and we've got a low volume of these solvents. The article I've got on the right here, I know it's pretty large and I don't expect you to read it all at once. I just wanted to give you an idea of what sort of documents we have available. This article is comparing the use of Xelsius with or without the condensation block. We can see that we have a much better rate of recovery for solvents when using the condensation block. All of these application notes that I'm going to be sharing are accessible, so just get in touch and we'll be able to share these across to you. Next is our external thermocouples. So an important factor that is often overlooked is that heating and cooling is dependent on the thermal capacity of the sample and the volume used. For most heating and cooling blocks, we're going off the temperature of our heating or cooling surface. There's always going to be a disparity between the heating element and the sample temperature. So to combat this, we use external thermocouples that sit that can sit in each independent position and is viewable on the software. So we just connect these flexible thermocouples to the back of our reaction module. We put it in the relevant vial through a rubber septum. We then can see exactly the temperature of our sample mid-run, and we can export as usual. And this sort of fine temperature control is really important in quite a lot of the applications that Xelsius is involved in. Here I've used crystallization as an example. It's absolutely critical that you've got a really good understanding of what your sample temperature is at all times when looking at these crystallization studies. Here's our inert workstation. So this is a really rapid way of inertizing all 10 vessels simultaneously, rather than doing this individually, perhaps using a balloon kit or individual attachments of a vacuum and nitrogen supply. So how does it work? For this, I'm going to get a little laser pen out so you can see exactly what I'm talking about. So hopefully you can see this laser pen. So at the top here, we've got our actual our rack of vessels. These are all connected via 5-port caps. We have a inlet for our nitrogen and an outlet for our vacuum. We then connect our nitrogen here and here, nitrogen here and vacuum here, apologies. We have a 3-way valve. It allows us to cycle between the vacuum and the nitrogen. We have proof that cycling from that vacuum 5 times is able to create a complete inert environment in all 10 of those vessels. We can then simply lift the rack off and put it inside our reaction block, where we can carry out any heating or cooling reaction. What a lot of labs like to do is have that nitrogen supply connected at all times. So while we're heating or cooling, we have nitrogen flowing through, and we then attach the last vessel in series to perhaps a gas bubbler, where we can just visualize that nitrogen is continuously flowing through and we're keeping that inert atmosphere. So there's a really wide range of applications in which this would be useful. In particular, just sort of specific chemical synthesis examples. Here, it's used in a imidation reaction. So we're performing the reaction at 20 degrees Celsius in an inert atmosphere for 5 hours. So with the inert workstation, we're able to set up that inert atmosphere really quickly in all 10 positions. We can then keep that inert during the 5 hours of the reaction. And using this method and using the inert workstation, we're able to collect some really good data, which proves that we're able to hold that inert atmosphere. Pressurized vessel. So these pressurized vessels sit directly into each position. Enables reactions up to 15 bar with a reaction volume of 0.5 mil up to 10 mil. They're also available in an analog display, which is able to integrate directly to the software. This way, on our trace, we'd be able to see pressure rising or dropping throughout a run. We have an overpressure safety valve, which will just release pressure above 15 bar to ensure safety. We also have a 3-way valve that allows you to sample gases mid-run. It allows you to release excess pressure, and it also enables you to add gases at the start of a run. A good example of this is hydrogenation. In this example here, they're actually using a balloon kit instead of the high pressure vessel. Of course, the pressure that you'd be able to create with a balloon kit is a lot lower than with a high pressure vessel. We are looking at writing an application report on this currently, and we're looking to see if adding hydrogen at a higher pressure is able to favor that reaction. Next is our dosing module. So this is an automated dosing station that is programmable with the software. So this allows for accurate dosing and sampling. We can pump directly from a reagent bottle to our vessels. Alternatively, we could be pumping from our vessels to a collection flask. It's completely programmable with the software and allows for automated control without supervision. There's a really wide range of applications with this again. So we can have automatic dosing of solvents, automatic sampling, time-controlled quenching of reactions, solvent and dissolution studies, and also exothermic reaction control. The application note that we're looking at here is looking specifically at a nucleophilic substitution reaction. So in this example, we're using the dosing system to slowly add our reagent pyridine at a constant flow of 50 microliters per minute for 3 hours. So as you can imagine, that would be virtually impossible without the dosing module. And it's in applications like this where dosing module is just an extremely essential part of a piece of the kit. Next is our photochemistry research kit. This is a really new one for us, only released in the last couple of months. So we've got a high current LED controller, which is able to drive photochemical processes. It's available in 8 different wavelengths, ranging from 350 to 660 nanometers. And it can facilitate up to 10 photochemical reactions all in parallel. In this example, we're using nitrogen bubbling alongside the emission of 455 nanometer light from our photochemistry probe to promote cyclopropionation. Again, we've got some really good data on this that we're more than happy to share. And finally, it's our 5-port caps. These replace our standard caps, you can see in the top left there. And these have 5 modifiable inlets and outlets, which enable flexibility and customization to your specific application. Potential applications, but nowhere near limited to. We could have in one inlet a direct temperature probe. We could have another vessel, another inlet. We could be having in an atmosphere. We could be doing gas bubbling. We could be sampling from the vessel. We could be performing flow chemistry and flowing reactants from one vessel to the next vessel within Xelsius. But of course, you can use any external accessory with this. It's just an inlet on the vessel. Next, just to sort of highlight the 5-port cap and also some of the other accessories that we've seen so far, I've got a really nice video which will sort of bring everything together. I'm going to talk through it. So here's the Xelsius reaction station. We've got the different vessels that we've talked about, the 5 mil, 30 mil, and PTFE vessels. Alongside the system, you'd have our chiller. This chiller connects directly to the reaction block, and it makes sure that there's no overheating of our Peltier modules. Here's our Peltier modules in action. As well as preventing overheating, our chiller also has a really important job of creating a temperature barrier between the 2 Peltier modules. That's the reason why we can have one cell heating to 120, 150 degrees and another in the negatives. Here's our reflux condenser, sits on the top there and promotes reflux. This connects directly to our existing chiller. As you can see, it's just promoting reflux within that reaction vessel. Here's our 5-port caps with our flexible thermocouple coming in first. Here in the example, you can see we're adding a gas, perhaps an inert gas. We're performing flow chemistry and forcing our reactants into the neighboring vessel. We could then come in and sample or perform any other reaction stages such as gas bubbling. So just to round off on all those applications that we've looked at now, there was a couple of accessories that we just don't have time for in today's session, including turbidity probes. It's a really big focus for lab tech to continuously release new accessories, and in doing so, opening the door to new applications. A really exciting development that's being worked on currently is the release of solubility probes. Alongside constant development in these accessories, there's a huge and growing list of applications. And what LabTech have tried to do is to condense this into a reaction notebook with some really nice examples of reactions that you could be performing in Xelsius. Alongside this, we have a library of different scientific papers and publications in which Xelsius have been used, often alongside our scientific collaborators. A lot of work's been done at the University of Turin, for example. All of these application notes and reaction notebooks, we're more than happy to share. So please feel free to get in touch and we can send some specific applications to you. Finally, I just wanted to finish off with saving with Xelsius. So as well as the superior performance that we've looked at, Xelsius can actually offer some considerable savings compared to traditional methods. We've got a nice return of investment calculator, and I'd encourage you to reach out to your local rep and we can help in calculating the potential savings with Xelsius. So I've had a go at just putting a bit of data on this. So what we're going to do here is compare the classic approach versus Xelsius. So in the classic approach, we're going to say that we're using 5 hot plates and 5 thermostatic baths. Even this wouldn't be able to replicate Xelsius. We need 10 hot plates and 10 baths to do what Xelsius can do. But for now, we'll stick to the 5 and 5 method. And if we look at that, we're using a 2.8 meters squared of footprint, and we'd say at least 3 fume cupboards. With Xelsius, we've got a footprint of 0.13 meters squared and taking up not even half a fume cupboard. Firstly, if we look at energy consumption over a year, we can see that there's roughly an 86% saving on energy consumption after 12 months. We've worked these numbers based on 8 hours of operation a day for 229 days of the year. And this translates to reduced carbon emissions as well. We're looking at 11.1 tons of CO2 not emitted when we switch between that classic approach and Xelsius. And finally, just the costs of that energy is really substantial. So if we were to do a direct swap from the classic approach to the Xelsius, we'd see roughly a £24,000 saved per year. Now, these prices are from 2023, but there may not be that much change. And finally, just to summarize, we firstly looked at the hardware and we saw that it's an innovative and precise reaction station with immense heating, cooling, and stirring capabilities. We've got a really intuitive software with complete data export options. There's an extremely wide range of applications, which we don't have time to investigate all of today, but we'd be more than happy to assist and advise on your specific application. And we've got a huge list of accessories and growing list of accessories that open the door to different applications. And finally, we just covered at the end there the potential savings. So by reducing our laboratory footprint and the number of fume cupboards we used, we're able to reduce our energy consumption and a lab's running cost. And finally, we're able to strongly reduce our carbon footprint. So thank you all for listening. That brings this webinar to a close. Join us for the rest of our webinars where we'll be sharing more information on different products. I believe Joe is still around to pass on any questions that you may have. If not, feel free to get in touch via our website or email sales@analytics.co.uk. Thanks again.
Excellent. Thank you, Alex. Before we go, we've just got time for one quick question at the end there. So the question that we've had is, can I use a combination of accessories in different cells or for the same cell?
Yeah, of course. So as long as they fit physically on top of the reaction block, you can use a mixture of both. So you could have at the back, you could have your high pressure vessels, and then you could perhaps have a photochemistry kit at the front, or any combination of different accessories. And that's really nice because it means that you can have shared use of the system. Different lab groups could be using it all at once, or if it's an undergrad project, you can have 10 different users all simultaneously doing different reactions.
Perfect. That is all we've got question-wise there. So with that, I'll say thank you everyone for attending and joining us this morning. and we will end the webinar. Thank you.